Hello, I'm Jenny Grosslight with Keysight Technologies. This video covers probing solutions for DDR and LPDDR memories using the U4164A Logic Analyzer system. In this video, we will cover a brief overview, go through DIMM Interposer selection, SoftTouch Pro solutions for footprints that get designed into systems, and BGA Interposer selection. We'll wrap up with a summary. Any logic analysis memory solution begins by connecting with the probing, which is the subject of this video. There are DIMM interposers, BGA interposers, and specialty midbus probing, SoftTouch Pro. The acquisition for any of the solutions for memory is always with the U4164A Logic Analyzer. Acquisition of the memory traffic is with the U4164A Logic Analyzer modules. Depending on the memory technology you're probing, you'll have different combinations of modules and module speed grade options. The B4661A memory analysis software has base software available at no charge and licensed options for specific technologies and views. The base software includes DDR scan for setting the proper sample positions for accurate state mode measurements of all DDR traffic. When considering any of the DDR or LPDDR solutions, they all use state mode, and the specifications of the logic analyzer make a difference in how the logic analyzer system is configured. Exceeding the 2.5 gigahertz results in an error message and no trace capture. For some applications, such as DDR5, there are interposers with a clock divider that divides the clock into the logic analyzer, and this doubles the coverage up to a 5 gigahertz clock from the system under test. This works for DDR5 when the address and command are operating on a single clock edge. The maximum specified data rate is 4 gigatransfers per second. This is a typical specification. The bit error rate of the capture will increase as the data rate exceeds the 4 gigatransfers per second. A second typical specification that will impact the bit error rate is the 100 millivolt by 100 picosecond eye at the probe tip. And this is at the RC component at the tip of the logic analysis probe. As the eye size decreases, the bit error rate will increase. The memory solution configurations are different depending on whether you're over or under the 2.5 gigatransfers per second data rate. This is because of the clock specification. Below 2.5 gigatransfers per second, the U4164A will clock off both edges of CK0 from the system under test. Dual sample mode is used to capture read and write DQ simultaneously at different sample points and different thresholds. This is because dual sample mode gives us two labels, two samples from each signal into the logic analyzer. Above 2.5 gigatransfers per second, to keep within the specification of the logic analyzer for the 2.5 gigahertz clock, we will be clocking off one edge of CK0 from the system under test. This means that we need to be in quad sample mode to provide 4 sample positions from each DQ probe point. 4 sample positions we require are DQ read rising, DQ read falling, DQ write rising, DQ write falling. The configurations use the rising and falling read and write labels, and the software decoder will reassemble the rising and falling samples for analysis. A few more details on the situation where we use a clock divider, capture DDR5 over 5 gigatransfers per second. This is where we put the logic analyzer into dual sample mode to capture a first and second edge sample for each of the CS and CA signals. These labels are created in the configuration. During tuning, the sample positions of the first and second samples are offset from each other by one eye. This is because we're taking both samples at the same time, but we want to be capturing what would be off the rising and falling edge of the original CK0. There is a specific DDR5 reconstruction tool in the configurations for the interposers that provide a clock divider. The reconstruction tool merges the first and second samples to create a state waveform that represents the DDR5 system. Only the CA and chip select signals are used in the 4 solutions over 5 gigatransfers per second. You'll choose the probing for your memory form factor. Interposer for DDR5, there is a specific interposer for RDIMM, LRDIMM, and then a different one for UDIMM. On previous DDR3-4 technology, the UDIMM and RDIMM and LRDIMM were all the same socket. That is not true with DDR5, so there are different interposers that connect to the different sockets. And then for DDR5, it's the FS2602 DDR5 SODIMM interposer for a small form factor DIMM. For chip down applications, there are two different methods. You can have a BGA interposer with risers or design in mid-bus probing. As you go through the decision process, the first question is, does your device under test have an RDIMM, UDIMM, or SODIMM socket? DIMM interposers offer the easiest, most flexible, and typically least expensive probing option, providing that the DUT has a socket. You can refer to our channel partner's website, futureplus.com, to determine the exact interposer for your system requirement. These interposers are sold through Keysight also. If your system does not have a DIMM socket, then the next question is, do you have influence over the design of the DUT? If you do, then you can consider designing in a Soft-Touch Pro footprint to the DUT or a validation board, and then use a Soft-Touch Pro cabling to bring the signals into the U4164A. Pros to this are that it's an industry standard footprint, it's connectorless technology, so you're not leaving extra hardware on your board. There's a reliable connection, and it's relatively low cost for the pros. The con is that it requires upfront design of the footprint on the board, and in some cases, real estate would be prohibitive to even add a small footprint. Now, if you don't have influence over the design, or you choose not to design the Soft-Touch Pro into your board, then you have an option to refer to the Keysight Memory Device BGA Interposer catalog and determine whether there's already an interposer designed for your system requirement. If it's not in the catalog, you can ask your Keysight representative about the custom BGA package-on-package interposer process, and you can have a quote for a custom interposer design. The pros to this is it allows probing of system memory signals from any system. The cons are that it requires BGA rework, and the BGA interposers are not considered reusable. Next, we'll go through the DIMM interposer selection. There are DDR5 RDIMM interposers available, UDIMM, and SODIMM interposers. Notice that for DDR5, because the speeds are going over the 5 gigatransfers per second, that for each of these there are options with the clock divider, so you can capture command address only at the higher data rates. And command address and chip select let you do complete protocol analysis and debug on the DDR5 bus. For the RDIMM interposer for DDR5, the FS2670 has not only the clock divider, but also a RCD. For the legacy, the DDR4 and DDR3, there are passive interposers available. No active interposers are required because the speeds aren't high enough to require. This slide shows a configuration that will work for any of the three DDR5 DIMM interposer solutions: the FS2600 DDR5 RDIMM, the FS2601 DDR5 UDIMM interposer, or the FS2602 DDR5 SODIMM interposer. Any one of those interposers to capture simultaneous read and write traffic with all command address and DQ from both subchannels off of the DDR5 DIMM. They will require a quantity of 4 U4164A Logic Analyzer modules, configured as 2 sets of 2 modules each. Each of those modules will require the option O2G speed grade and quantity, and an optional user preference for the choice of memory depth. You'll need an M9505A chassis. We recommend the M9537A embedded controller, although there is an option to get a cable and a PCI Express card to use your own host. And you will need the quantity 1 of the B4661A memory analysis software with the licensed option for DDR5 analysis and compliance validation. The interposer shown on this slide is the FS2601 DDR5 UDIMM interposer. It is in the socket with the UDIMM installed on top of the interposer. The interposer has direct connect cabling to route into the 4 logic analyzer modules. The M9537A embedded controller occupies the bottom slot in the chassis. The B4661A software is installed on the embedded controller. With the FS2670 active DDR5 RDIMM interposer that can capture the command address up to 6400 megatransfers per second. This captures command address and chip select only, no DQ. To capture both DDR5 subchannels simultaneously, you will require 2 of the U4164A Logic Analyzer modules, 1 required per DDR5 subchannel, and each of those needs to have the option O2G speed grade option. You'll want an M9505A chassis, the M9537A embedded controller, and the FS2670 DDR5 active RDIMM interposer, along with the B4661A memory analysis software and licensed DDR5 analysis and validation option. The active components on the FS2670 include an RCD, which operates in pass-through mode and decelerates and applies DFE for the CA signals and chip select. There's a clock divider, which divides the clock into the logic analyzer so that that clock input stays within the logic analyzer specification. For this active interposer, the user needs to provide a BIOS that allows the device under test to boot with the active interposer installed. Contact your Keysight rep or Future Plus for further details. Now let's cover SoftTouch Pro solutions, where you design a footprint into the system. There are 2 cables to consider for capturing DDR3, 4, and 5 or LPDDR3, 4, and 5 traffic. The E4506A Pro with quantity 2 U4201A cables can be configured to operate in dual sample mode and capture the DQ for the memory all the way up to 2500 megatransfers per second. This will provide you separate sample positions for read and write. Anytime you go over 2500 megatransfers per second, the only SoftTouch Pro probe that is going to let you capture the data is the U4206A. The U4206A routes signals from the footprint for proper capture into quad sample state mode. It routes the signals into the even inputs on odd pods of 4 pod pairs. This means that one U4206A, the routing from it will fill up an entire U4164A if you're putting all the pods into a single U4164A. Using it for slower mode captures will work. You can always slow the system down and go into dual sample or normal mode. However, keep in mind that the routing of the cables is still going to use up 4 pod pair inputs. Design recommendations. Placing the SoftTouch Pro connectors close to the DRAM generally gives you better eyes than going mid-bus. Drivers in the DRAM are typically weaker than the memory controller drivers, so it helps to be closer to the DRAM. And also the location near the DRAM can help minimize reflections. Where possible, use flow-through routing. Flow-through routing is where the traces are on the top layer of the board and go through the pads of the SoftTouch Pro. This isn't always possible. When it's not, and you have to have a stub from an inner trace layer. Try to keep the number of vias, and particularly the length of the vias, to a minimum. Stubs increase loading and reflections. This will result in degraded eyes to the U4164A and create disturbances to the system under test. Considerations for designing the SoftTouch Pro probing into your system. Run simulations on the entire system with and without probing. This will help you understand that the loading on the system will be tolerated and ensure that you have an adequate eye for the logic analyzer data valid window, the 100 picosecond by 100 millivolt for the U4164A at the SoftTouch Pro pads. Ensure that the signal routing meets the logic analyzer requirements. Clock needs to be routed into one of the 2 clock inputs, and a clock qualifier, if applicable, depending on the memory technology, routes into a clock input also. This is the SoftTouch Pro load model. It's the differential model, so if you're routing a single-ended signal, you can ground one input for single-ended simulations. The point that you want to view the simulations to see what the eye size looks like for the logic analyzer is shown right in front of the 20K 0.35 picofarad tip RC. The input to the logic analyzer then is modeled as a 75 ohm transmission line into 750 millivolts. This is an example of an LPDDR5 footprint. So the specific rules for pin assignments for LPDDR5 are rather simple. The differential clock, CK0, must be routed into either the A7, A8, or B20, B21 differential clock inputs on a SoftTouch footprint. For each LPDDR5 channel, make sure that you keep all of the signals from the same channel in the same pods. Because the pods are going to go to different logic analyzer modules for different channels of the LPDDR5, you need to make sure you're not mixing signals from one channel with another inside one pod. So pod 1, if it's channel 0, would have all channel 0 signals. You might choose to put channel 0 on pod 3 also. Channel 1 would go to, in this drawing, channel 1 would go to pod 5, and you could choose to put the rest of channel 1 onto pod 7. Any CA or any DQ within a channel can go to any of the no connects within a pod that is dedicated to that channel. For LPDDR4, the rules for pin assignments are similar to the LPDDR5, with the exception that LPDDR4 has a clock enable. Therefore, you will want your clock enable to go into a clock input. So pods 1 and pod 5 need to have signals from the same channel on them. If you want to try to have signals from another channel on the other pods, you need to be having another footprint where you can bring the clock and clock enable in for the other channel. So you might as well keep the channels on separate footprints. CA and DQ on LPDDR4 can also go to any of the no connects in the diagram. Anytime you change pin mapping, you need to make a new configuration for your footprint. Recommended configurations. For LP5 or LPDDR4, a configuration for CA and 16DQ, you'll need a minimum of one U4164A module with option O2G for each LPDDR4 or 5 channel that you want to probe simultaneously. You need at least one M9502A or M9505A chassis. We recommend an embedded controller and at least one U4206A cable, and that would be per channel. The quad sampling features of the U4164A module are required to capture the DQ of DDR4, DDR5, LPDDR4, and LPDDR5 for signals above 2.5 gigabits per second. In quad sample mode, 4 samples are captured per clock edge at 2 different thresholds. This is the read rising, read falling, write rising, write falling samples. Quad sample state mode is only available with the U4164A O2G licensed speed grade option. For LPDDR5 command address only, when you don't care to capture the DQ, a U4164A option O1G is sufficient for up to LPDDR5 11.2 gigatransfers per second data rates. This is because CA will only be operating up to 2.8 gigatransfers per second, and the option O1G is sufficient for that when using dual sample. To create custom configurations for your different LPDDR4 and LPDDR5 footprints, use the DDR Custom Configuration Creator tool to make the unique state mode configurations. The tool is installed with the base B4661A memory analysis software. Use of the tool provides proper labels for the software tools, the DDR triggers, and DDR setup assistant. Gives you proper scan windows for the state mode. This is to set sample positions, and it provides scan triggers for state mode sample position setting. The use of the tool is critical to get your configurations correct. Use of DDR setup assistant is also critical so that the system does work for you. The DDR custom configuration icon is on the lower left. It will open up and give you pull downs where you can choose the view of the SoftTouch footprint to match what's in your schematic. And then you follow the pull downs and fill in the signals as they are routed on your board. The next section is an overview of DDR BGA Interposer selection. The memory device BGA Interposer catalog has solutions to connect to a scope for signal integrity measurements or a logic analyzer for protocol measurements. They are grouped by the memory standard and also grouped by whether they're for signal integrity with the scope or the logic analyzer. We'll review a few of the interposer options from the catalog. The DDR5 by 4x8 78 ball interposer is shown on this slide. What we have shown is the W5643A with command address capture up to 2.5 gigahertz for 5 gigatransfers per second, and the DQ up to the 4 gigatransfers per second. That restriction is the specification of the Logic Analyzer's highest data. The configuration required will be one U4164A Logic Analyzer module with the option O2G speed grade and the choice of memory depth options. An M9502A chassis or the M9505A chassis, the M9537A embedded controller, one W5643A DDR5 BGA Interposer, which comes with a riser, and quantity 1 each of the U4208A ZIF cable and the U4209A ZIF cable. You will also need the B4661A memory analysis software with the licensed DDR5 analysis and compliance validation option. There's a trimline version which has the pin 1 offset in the keep out volume. This is for systems where the DRAM is located tight up against the controller and may not have enough room for the W5643A keep out. The configuration is the same as for the W5643A. The actual software configuration that gets loaded will be slightly different. Here we have an example of our next generation DDR5 8 gigatransfers per second interposer. This BGA interposer is the 78 ball by 4x8 DDR5 interposer that has a clock divider on it for the clock into the logic analog. We are only capturing the CA, CS, and the divided clock by the logic analyzer. There's no DQ capture. And the divider keeps the clock into the logic analyzer at half of the device under test clock frequency. This keeps it within the logic analyzer's 2.5 gigahertz clock input specification. Once you go over DDR5 8 gigatransfers per second data rates, data rate of the DDR5 CA is going to be starting to exceed 4 gigatransfers per second, which is the LA typical specification. And above that speed, you'll likely experience increased bit error rate on captures. Above DDR5 10 gigatransfers per second, the divided clock into the LA will exceed the LA clock input specification of 2.5 gigahertz. BGA rework. Keysight recommends that interposers are installed by companies with specific expertise in this advanced type of processing. Rework guidelines vary between interposer designs. Make sure to request guidelines from your Keysight representative that are specific to the interposer you are using. BGA rework for interposers is challenging. Some users are choosing to install the interposers onto a gripper socket, which is ordered separately from Ironwood Electronics, instead of using a riser. Sockets have the advantage of reuse. Risers typically have better signal integrity. In summary, Keysight offers a wide variety of DDR and LPDDR probing solutions for use with your U4164A Logic Analysis system. You can choose between DIMM interposers, Soft Touch Pro designs, and BGA interposers. Thank you for your attention.